If you are into DevOps, SRE, coding, or cloud engineer, one common factor for all the job roles is the CI/CD, and which we can't skip it. In this video, we will be deep diving into GitHub Actions, which is a CI/CD tooling, so that you can write your own use case based on the requirement and demands. To start working with the GitHub Actions, we might need a GitHub repository at first place. Create a repository. So I'm creating a Git repository for the demo purpose called Git workflow. So I'm keeping the repository as public and the create repository. So in your case, you would be, if it's an enterprise account, then you would go with private, and the configuration might change. But since we are trying to do a demo as free, I'm creating the repository as public. So let me get the repo clone. I will use git clone and the cloning part, so that now the repository will be cloned, and if I go for, I can open the same thing in the VS Code. You would see there is no actions as of now currently running in our repository. So in order to configure a simple workflow, what we would need to do is we would need to either you can go here and say configure, or there are like multiple templates provided, and you could see here like it starts with name and the components of on branches and XYZ stuff goes on. And if you see, everything is written here in the YAML format, and the file structure to get the actions going on is you create a folder called .github, and then within .github you will create a folder called workflows, and then you create a file. It can be any name, and it should end with the extension YAML. So either you can go here and directly straight away create from the console, or if you are doing it in the local VS Code, what you can do is, so I already have a pre-written template just for the demo purpose. So I'll just go here. So first you create a folder called .github, and within .github you'll be creating another folder called workflows, and within the workflows you're going to create your file, let's say demo workflow, and I'll name the file with the extension YAML. And so this is how the syntax is going to look like. Don't worry, we'll deep dive into like each and every component. So one thing you need to know is the structure of the syntax, how it's written. So for example, you have a jobs, and anything within the jobs, it's been given with a 2 space inside, and then this is a job name, and within the job name again it's been a 2 space has been provided. How the intended is made is to be something you need to focus. So if anything like sub, or if you think something should fall one under another, then you are going to intend it into like 2 specific spaces. Okay, so we'll go deep into it, but we just get the idea or get the taste like how it's going to look like. So what I'm going to do, I'm going to push this into the remote repository. So the command I'm going to use for that is I use git add dot git commit add job 1, and I'm going to say git push origin. So in case if you have never done the git commands, we already made a video like how the files get staged from local to the remote repository, and same way how you can do the rollback. So in case if you haven't checked that, I would highly recommend to do that. So as soon as once you see the file has been pushed to the remote repository, you see the actions get started flowing in. So you can see here like some things is running, and you could see the job name and the all our commands, it started executing line by line. So now let's deep dive into it. So here when we talk about the syntax of the YAML or the GitHub Actions syntax, the first thing you see is the name of your workflow. So this is going to be seen where it's exactly the left side of your action. So once you go into the actions page, you see the name whichever given as the initial part, it's going to be get displayed over here. So the GitHub Actions demo, the same name which is going to, so it's going to easily identify. Let's say if you are creating multiple workflows, and if you want to categorize it so that you can just go straight into it and see if any workflow is succeeded or failed. For those kind of things, you would need to know this. Then you have the run name. So where this run name is going to reflect is where the running is happening. So this is going to be the run name. So let's say if you have multiple runs for multiple specific purposes, then you would need to know what run is happening. And then you have the explore GitHub Actions. So if you see, that's going to be the job name. So we have seen the workflow name, run name, and then the job name. So all these 3 things you would need to give so that we can easily identify like which job is running, which workflow is running, and which run is running, right? So let's say if I want to create one more job, I can just to make it simplified, I'm just going to copy the same template as of what we have had already, and ensure that it's going to be in the same line space. And one thing you would notice is that the job names can't be repeated. So since we already used the explore GitHub Actions over here, I can't repeat the same name here. So maybe I can say job 2, and the rest everything can be remains the same. Okay, so now I will just again push the changes to the remote branch. Okay, so now if I once do the changes, you would see the next run automatically began. So this thing, something we call it as trigger. So how the GitHub Actions knows that it should run the branch again at this point of time. So I'm performing a change, I'm pushing the code to the branch. It's not the action change, but any changes to the code to the branch, it can detect it and it's executing it. And now you see it's could able to see the two jobs are running parallelly, because that's how the execution would be, because there is no dependency, because we haven't told there is any existing dependency for the GitHub Actions, so it's just going to run parallelly. There can be cases where you want to make it sequential, like to run one after another, so for which we can say we're just going to use the block needs, and you would say the job name itself. So the job name here is it's going to be this. So here all we say is the job 2, it's going to depends on the specific job 1, the job name of the 1. So if I again do the change, and let's say dependency, and I can do git push origin main. So now you would see the change of what would happen of adding the job dependencies. So you would see the job 1 would execute, and then the job 2 will start execute. So in case if you want to run sequentially, not running it parallelly, then you can have this option of adding the needs block. In case if your jobs is having dependency of multiple jobs, so in our case we just added needs of 1. In case if your jobs is having dependency of multiple jobs, you can just convert it into an array and add the job names separated by a comma. Okay, so but I think in this case we'll just leave as it is. And for the question like how GitHub is able to detect of our changes that we pushed it, comes the part of on parameter. So the on parameter says where or when the jobs to be executed. So you can configure multiple scenarios here, like you can say push, pull request, or fork the. So you can add multiple subfilters towards the on to say a specific branch or specific conditions only to do it. And also you can use scenarios like schedule, so that you can add multiple cron job, so that it's going to execute say every 9 o'clock the job should run. So those kind of multiple things can be triggered by using the right value for on. So then we have seen jobs. The jobs itself is of to declare the number of jobs, and then we added the sequential flow, like how the job should be. So then you see something called runs on. So the main purpose of CI/CD is that you are going to execute your commands remotely in a centralized server, so that we don't need to worry about the server configuration, we don't need to worry about the credentials, we don't need to worry about the how the file is going to be execution. Let's say we are going to run a sequential of command, we don't need to follow any workflow or workbook saying that the command should execute in this specific order, or the task should be done in this XYZ order. So it's all configured and regularized. So once your job is succeeded, as you're going to keep on running n number of times, you're going to get the same result. That's the beauty of using the CI/CD and the GitHub Actions itself. So now the use case can be vary from person to person, use case to use case. So people have jobs specific for linting. Let's say you go for, if you're writing a Node.js, you might need to validate the Node.js itself is properly written, or like all the syntax conversion is followed. Same like if you're using a Terraform, you can use Terraform linting, or you can use Terraform FMT, the formatting one. So all those things can be done as a sequential of jobs by executing the commands. To execute the commands, you are going to use steps and then the run parameter. So in the run parameter, you would be mentioning the what command it should be executed. So you can say, so it's just printing it echo, but you can also say like Terraform format or what you want to do with. So now the runs on is the part. It's like a OS in the centralized one. Which image your GitHub Actions should use it? So GitHub provides multiple options. You can attach your own server, the EC2 instance from AWS for example, or you can use the pre-baked images which is provided by the GitHub Actions. So in this case, we use Ubuntu's latest image, and then all our commands are going to execute from that. And you could see you can also provide the name for your runs. Let's say if you're going to execute specific command and you want to identify what command it is, and you can give a specific name with the name parameter. And then you have users. So let's say, and then if you want to reuse the same workflow in some other flow, or let's say there is some common module or some workflow if you want to reuse in your project, then you can use this parameter users, which is going to say the owner. So in this case, it's the repo owner is Actions, and then the repo name itself is the checkout, and the tag of the version you want to use it. So I can show you quickly. So if I go for the GitHub page, so same way like how you see tech page and Git workflow EV or repository, there would be another user or another owner called Actions. And if you go here, like you can go for, you can search here Actions, and should be able to see you see the Actions as a owner. And this Actions, it's going to contain a specific repository called checkout, and in this checkout they're going to have multiple tags. So and we are using the v3 tag here. So you can reuse the any workflow which is currently existing in any of the public repository using the keyword the owner / the repository name and any specific tag which you want to use. In case if you want to pass any specific value to the workflow which you're using, then you would be using something called width, and then you would pass the parameters to it, so that while executing the workflow or while calling the workflow, the parameters which you are providing will be passed as an input to that specific workflow. So these are the generic things which you would need to keep in mind or to get started, because at the end of the day we are going to execute our commands in a remote part. And the GitHub also provides its own inbuilt variables, something like the GitHub workspace or the GitHub actor, like who is running your pipeline. It's going to give the those details, so which comes handy in multiple places. Hope you get the basic idea like how the syntax would look like, and how to start getting started with the workflow itself in the GitHub Actions. I will share you the official documentation of the GitHub, which contains the each and every parameter which we are discussing, and there are like n number of parameters with detailed documentation and examples. Like for example, you see here like the inputs itself, like if you want to pass specific inputs, or if you want to set a default value for your workflow, then you can use defaults, which are like more self-explanatory. And I would highly recommend you take any one use case. Let's say it can be printing an echo command to say like hi, and then who is running it, like GitHub.actor, or you can say like run a Python command, right? So use the image which you would need for Python, or run the command to install the Python in the base image in case if it is not there. So try experimenting it. you don't need to start with like more complex things like deploying it in a Docker or stuff around that. But end of the day, you are going to execute command. Let's say if you're deploying in a Docker, you're going to run the commands under the run section to deploy OS1, and then you are going to pass the secret. So try experiment it. So if you want to deep dive into it, I would highly recommend go each and every of the component. Each and every example has been provided in detail. So experiment it, get your hands dirty. That's the best way to start learning the GitHub. And so this is even in terms of entry perspective, they expect you the basic. Do you know able to configure a jobs? Do you know how to create a dependency of the jobs? And do you know how to handle the secrets while passing the jobs? So these are the minimum requirement if you are looking for any entry level to execute the GitHub Actions itself. Yeah, so hope you find this video useful. Do comment in case if you need us to cover any other more specific use case or any other DevOps, cloud or technological topic which you would like to see from us. If you find our video useful, leave a thumbs up so that the YouTube can promote our video to a wider audience. In case if you have any freshers in your team or your peers, do share this video so that let them also get started experimenting the workflow, how to kickstart it, right? So for more videos, do subscribe our channel. See you at another in the next video. Until then, Tata bye from Vasan. Thanks.